Good morning. We are working our way through the inference part of our course. I'm in section 6.2 and I'd like to talk to you about the t-distribution. T-distribution is very similar to normal distribution as far as some of its properties that are listed. If you take a look, you can see some of them here in my document. Properties of the t-distribution: the mean, median, and mode are equal to 0. That's the same as the normal. It's bell-shaped and symmetrical. That's also the same. Total area is worth 1. But the tails are a little bit thicker, and the standard deviation varies with sample size. So we are going to pay attention to sample size for this one. The last piece of the properties of t-distribution is this 6th point here that says that it's all these families of curves, and they have something called degrees of freedom. This has to do with their sample size, and degrees of freedom is defined to be the sample size minus 1. The best way to think about degrees of freedom is if you had a classroom of 30 chairs and there were 30 students. 29 people have a choice on where they sit, but the 30th does not. Okay, so the first thing I just want to do is practice reading the table. So I have a copy of the table here, and if you notice, it lists degrees of freedom over here on the left-hand side, and then across the top, depending on what you want to do, it's either going to have confidence level or tails. And so confidence levels have to do with our confidence intervals. You can see our table only allows us to do 5 different values between 80% and 99%. So that's what we're going to stick to for this morning. And you can see that degrees of freedom gives you very large values for t. So this table is backwards from the normal distribution. These values here are your t values. And then up across the top has to do with your area. Okay, and then again, it's specific to the degrees of freedom. Okay, so for example, if we were looking to do a confidence interval and we had a sample size of 15, then we would actually look up degrees of freedom of 14, and across this line are all the critical values for t based on your confidence level. So if we wanted to say a confidence level of 0.98, then we come over here, and this is the column for 0.98. And so our critical value for t becomes 2.624. Ta-da! Easy enough, correct? All right, next video will show examples of how to use the t-distribution. The only other thing I want to talk about in this video is how do you know if you need z or if you need t? So if you look here, this is one of the slides from 6.2, and the first thing to ask yourself is, do you know sigma? Most of the time the answer is going to be no, okay? But if it's yes, then you are going to use a standard deviation if the population's normal or n is 30. If it doesn't fall under either one of those, then we have a totally different test to run, and that's a different course. Sigma is most likely not known, and so you would answer no to this question. And either the population is normally distributed or n is 30, then you can use t. So you still need the population to be normally distributed. Otherwise, you need the sample size to be large, is how your textbook looks at this. But to be really honest, there's some wiggle room in that. So keep in mind, for the most part, if sigma is known, we're going to use z. And if sigma is unknown, we're going to use t. The catch on both of these is that you still want normal distribution. Otherwise, the sampling does not behave the way you want it to. Okay, thanks. Stay tuned for video 2 from 6.2 to see some examples.